Hello everyone, in this we will discuss the light emitting diodes used as a optical source. So basically for photonic communication in which we require data rate of 100 to 200 MB per second, in that we will prefer this LED as a optical source. So basically there are two types of LEDs used in the optical fiber communication. One is a surface emitter and another one is the edge emitters. So basically in LED we are using gallium. We are using the gallium material, and usually the LED, red LED or green LED, all these are the homogeneous LED. But here in optical source we are using heterostructure for the LED. So what do we mean by this heterostructure? Basically in this there is the change in the doping level as well as the refractive index. So here you can see in this diagram the structure of hetero structure light emitter, that is LED. In this, here you can see these two are the metal contact at the terminal end. Then there is a one layer of N type of gallium arsenide substrate. And then here you can see there is a layer of N-type gallium, aluminum and arsenide. Here X is the mole fraction of this particular atom. So the width is near about 1 micrometer, and this is responsible for the guiding the light and carrier confinement. Majority or minority carrier confined in this particular area portion. And this is the again recombination region, and in this here y is representing the mole fraction and the width is around zero point 0.3 micrometer, and this is the reason where this is the particular area or space where the recombination of majority and minority carrier will take place, and as a result photons are emitted. And after this there is a p type of semiconductor material, and these two layers n-type and p-type, these both have the same width and responsible for the carrier confinement. And this is last layer, p-type gallium arsenide. This is the improvement layer, or we can say this is the substrate. So these two are acting. So in heterogeneous structure of LED, the constituent on doping level of the material is not same across the whole width of this diode. Here there is a variation in the doping level, variation in the mole fraction of different material. Here material is also different. Here we have used gallium arsenide as a base substrate, then gallium aluminide arsenide for the different purpose, and one more different fraction of this as a recombination reason. So, and this is the heterogeneous structure of LED. And in this, here these dotted lines show this area. So this recombination reason, here hole, electron and hole will recombine, and this is the energy Eg. 1.51 electron volt is the Eg, energy gap. And as a result, recombination of charge carriers, majority or minority, will take place in this region, and as a recombination, photons are emitted. And for particular this structure, this combination of this mole fraction will achieve the photons of wavelength 820 nanometers. So in this graph you are seeing the energy band and hole recombination, and in this last graph, see, here you can see there is a change in the refractive index as we move from this left to right, from left to right, this metal contact, from N-type semiconductor to this P-type gallium arsenide semiconductor material. So in substrate, the refractive index is lowest, and in the recombination region, this is the recombination region, and in the recombination region, the refractive index is higher, and this particular area, light guiding area, recombination region, this region is the waveguide region. So this is the structure of heterogeneous LED, and this formula lambda micrometer, this is showing the wavelength, and wavelength of emitted photon can be calculated at 1.240 divided by EGEB. This 1.240 is the product of hc. H is a Planck constant and the c is the velocity of the light. So in order to identify the or calculate the wavelength of emitted photon, we will use this formula. So this is all about the heterogeneous structure of the LED, and for optical source we are using only heterogeneous structure of LED, as this is providing carrier more carrier confinement, and there is a graded doping level across the whole length of the diode. And now next we'll discuss about the surface emitting LED and edge emitting LEDs. Thank you.